Welcome to D-Lab. For the year 2020, I want to return to some of the basics that I used to enjoy doing. And that was taking something of no value and turning it into something cool. Like repurposing old equipment into guitar amps. So you guys can enjoy it. And that's what we're going to do in this new series of repurposing equipment. So I have a piece here selected. Let me show you what I'm up to. And we'll have a multi-part series. We'll go step by step how you can create something like this yourself. All right, here's our candidate for repurposing. It used to be an old crystal marker generator made by this Polytechnic company, okay? It's the type 909. I probably picked this thing up at a ham fest for next to nothing, but I thought the cabinet was really cool. I love the artwork. And I thought, you know what, this would be a great little guitar amp. So let's see if that's possible. All right, here's the chassis. All the tubes except for the rectifier are missing. And this just happens to be a 5Y3. You got a big massive power transformer made by Freed. That was a very vintage transformer company. Got a can type filter cap, which I'm assuming is probably bad. And a choke. And then you can see the sockets from the old tubes that were installed, and it's all built on a nice, I believe, aluminum chassis about 3 inches tall. So there's plenty of real estate here to create an amplifier. Let's look underneath. Now here we are, bottom side. You can see your AC input goes into some crazy filtering. This is obviously military grade. Look at the lacing of the wire harnesses, okay? This thing's beautiful. So there's our rectifier, there's a filter cap, and from there it goes into the rest of the circuitry, which we're not going to use. But what I want to do first is see if the power supply is okay, because I plan to reuse that. Obviously the power supply is bad. This is probably just going to go into the garbage, right? Because I need those components to get this project going, because that's the most expensive component. So what I'm going to do is we're going to power it up using my newest Variac. You guys just saw that in a video a few days back. I want to go ahead and give her the trial run. I have not used it yet. So we're going to hook up the Variac to our new Perspective guitar amp, bring up the power supply, monitor it, see what we're dealing with, see what repairs would be necessary to save the power supply. So the fuse holder that's on the back of this unit is missing the cap and the fuse itself, but it doesn't matter because I'm using my Variac, which has fuse protection in it. And what we're going to do is these two terminals are actually the AC line that's going in and feeding the unit. So I'm going to hook up my cheater cord, all right, and then we're going to bring up the Variac while we watch our current and make sure that we don't have any shorts. But first, let's get a meter hooked up so we can see what the DC output is coming off of that 5Y3. So here we go, smoke test. Remember, I have not isolated or interrupted this circuit at all. So if there's problems, we're probably going to see them. All right, I've got my meter hooked up to the 5Y3. I'm going to bring up the Variac. Watch the DC voltage over there. Here she comes. So we're getting output, good sign. I'm up to about 50 volts input. I'm starting to hear something I don't like. You hear that? So the power transformer is vibrating. That's not a good sign. My guess is either the laminates in the transformer are loose, causing a mechanical vibration, or that filter cap is probably leaking and loading down the power supply and it's pissing off the transformer. So let's pull out the 5Y3 and do the same test. So there's the 5Y3. I'm going to bring the Variac back up and see if we have a mechanical vibration issue with the transformer. So I'm up around 75 volts. I'm hearing nothing. That's a good sign. Let's put our meter on AC and look at the output of that transformer itself. Alright, what I'm going to do here is just look at one side of the transformer to ground, which would be the center tap, because my meter is only rated for about 750 volts AC and I really don't want to blow it up. Alright, so we're going to bring her up here. There's 50 volts input. What do we got? 204 volts. This is going to be a pretty hefty output transformer. So there's full voltage, 120. What do we got? About 455 volts unloaded. And the transformer is not vibrating. So obviously the filter cap is the issue. So what I'm going to do at this point is disconnect that filter cap. We'll put in another filter cap, a load resistor, bring this thing up so we can see what the actual output of that power supply is. Alright, so the AC is disconnected. And what we want to do is totally isolate this DC power supply from the rest of the chassis. Alright, we don't want anything to influence the output of that transformer. Okay, so that obviously totally isolates the power supply from the rest of the chassis. So I'm going to get this filter cap out. We'll substitute in another filter cap, add a load resistor, bring the power supply up. Alright, so there is where the old filter cap used to reside. This is a 450 volt cap. I've got a 500 dual section that I'm going to put in its place. We'll rewire it to the 5Y3, see what we get for DC output. Alright, there's our new filter cap installed. This is a CE distribution dual 32 microfarad cap at 500 volts. Okay, so we'll end up putting the 5Y3 back in, but first I need to get this thing wired up, and then we're going to hook up a load resistor, test the power supply. So this filter cap does not have a common ground on its case. It's actually floating, so it has a negative terminal. And what I'm going to do is wire that to this little terminal lug that is screwed down to the chassis. Okay, so we'll get that soldered up. Grab my clippity doodads here. So this is the ground. Get that soldered up. Okay, so the ground's connected. Now we need to hook up the hot off of the 5Y3, and it does have a choke here, so we'll go ahead and utilize that choke and make sure it's good too. So the power supply cap is wired in to the 5Y3. It goes through the choke and is sitting on this terminal of the cap waiting for a load. So I'm going to assume that I would like around 50 milliamps of current, okay, because we're going to probably put a class A circuit in this thing. So if I said, alright, I got 500 volts, I'm going to divide that by 10,000, which is my load, 50 milliamps, okay? So if I times that by the 500 volts, it's a 25 watt load. And guess what I have? Right there, 10K, 25 watt resistor. So that is what we'll initially load the power supply with, monitor it with our meter, and see if it can deliver that current. Here is my AC input. There's my meter. And I want my meter going to this terminal of the filter cap because that's going to go through the choke. So now we have our load. And we'll put the low side to ground about anywhere. Okay. Take our high side. And we're going to hook that to the same terminal as that filter cap. Okay. Lay it down here. I got my variac hooked up. I'm going to bring her up. Oh, you know what I should probably do though? Put in the 5Y3. Wouldn't get much otherwise, would we? Alright, here we go again. The load is hooked up. 5Y3. Everything's there. I don't see any issues. I'm going to bring up the variac. There's about 50 volts. Let's watch that meter. See the voltage ramping up. Now remember, this time we're under load. So whatever we end up with will be our usable DC voltage. Okay, so there's 50. Remember, it's a 25 watt load. It's a 25 watt resistor, so it could start getting hot. Right, here we go. Bringing it up. Pulling about ½ amp. Remember, we're really loading this thing up. There's my voltage. So even at 50 milliamps, yeah, I'm sitting right there at, you might as well say, close to 500 volts DC. So this is one hefty power supply, guys. Got to be super careful what tube you pick for an output tube, because if you use a 6V6 and hit it with 500 volts on the plate, probably pop it. So it looks like this is going to be a 6L 6 amp if we go Class A. So I got thinking maybe we should try a different rectifier tube. This is a 5Y3. Here is a 5U4. Okay, 5U4 is good for a lot more current, and of course has a different voltage drop than the 5Y3. So same deal, got the load, bring her up on the variac. Let's watch her voltage output. I prefer to use the 5U4 because the 6L6 is going to pull more current than what this 5Y3 can deliver. So there we are, full output, and you can see we're going way over 500 volts. Or 525 volts. This is a pretty hefty power output transformer here, guys. Probably going to have to put in a different filter cap. Alright, the underrated filter cap issue is resolved. As you can see, it's gone. But now, I've got these 4 caps over here. And this is what I did. I took some of these 400 volt, 68 microfarad caps, and I wired them in series. So that's half of that capacitance, so it would be approximately 34 microfarads, but it doubles the voltage, so now we're good up to 800 volts. I've got those all wired in. They're going back over to the, well, in this case, the 5U4 rectifier tube. So let's fire it up and see what we get. So you may be asking the question, is this good practice for filter caps? Well, if you look at some of the earlier Fender schematics, they did the same thing. They ran 350 volt caps in series to get 700 volts. So this is pretty much the same thing, just a different style cap. Alright, so I still have my load resistor hooked up. Meter is looking at the output of the 5U4 back on the variac. And bring it up. Should see the voltage coming up here. There it is. I'm only at about 55 volts on the input right now. So you see about 226, 227. Let's take it up to where we see around 300 even. This is the beauty of a variac. Got to get one for your shop. Alright, so you see we have about 300 volts. So since these caps are in series, take your meter and you go to the center point, you'll see half that voltage. So let's bring her up full bore and see what the applied voltage is to the filter caps. Remember, I'm still pulling about 50 milliamps through our load resistor. Coming up around 536, 37 volts. So that original 500 volt cap that I was going to use probably would not have lasted too long. And then you imagine that old original 450 volt cap. How did it survive? Well, back in the day, the line voltage wasn't as high as it is today. So more than likely, this power supply did not exceed 450 volts. But now with modern power coming into these appliances, it's higher and the transformer is going to give you more output. So that's what we're dealing with. But at this point, we are safe. Now I'm going to land tube socket in the hole where the filter cap was, and that is where our output tube will reside. Well, now that we have the power supply under control. We've updated our rectifier to a 5U4. I'm electing to use a 6L6 as the output tube. Now I have to remove the rest of the items from this device that we're not going to use. We're going to maintain the power light. This will be our input, and in this area we're going to have the 12AX7 that drives the output tube. And then somewhere we have to find a location for the output transformer, which I'm guessing will be over here in this footprint. So I ended up finding the proper fuse cap, so the fuse is installed, 6L6 is in place, and of course a rectifier. Next step, gut this thing out, get it rearranged, start turning it into an amplifier, which we'll do in part 2. Well, I hope you're enjoying this new series of repurposing old equipment into something cool, like a guitar amp in this case. So part 1 is complete. I have the power supply repaired. In part 2, we're going to start reconfiguring this little guy into a single-ended 6L6 hot rod amp. We'll see you then.